Hello and welcome to my channel. In this video, I'd like to show you how to make some interactive grass. As you can see, this grass behaves similar to the grass in the game Tunic, where it bends around the player, and it's a little chunkier than other grass in other video games. As well as it deforming with the player moving around, it can also deform with multiple entities, as you can see here, and it is quite performant, as long as you don't put too many entities or too many pieces of grass. But even so, it can still scale up all right. Anyway, let's get started by going down here, and I'm just going to create a new folder here, and I will call it tutorial. And inside of this tutorial folder, I'm going to go to create and scene, and I'll make a new scene called tutorial scene. And there are just a few things I'm going to copy over, so I think I want my camera, my volume, and let's just do that for now. I'll get rid of this and this. Actually, I'll keep the directional light. I'll just paste the other two things that I had. And let's set up the scene a little bit by adding a plane, and I will center it, and I will scale it up. And let's go ahead and create a green material just to make it look better. Put that on the plane and change the color to green. So rather than recreating the grass prefab I already have, I will just drag it out here and I will show you what it looks like. So it has this grass script on it. It has a mesh filter and a mesh renderer and a box collider, and the mesh that it's using is one that I created in Blender, and it just looks like this. You could probably get more performance by doing a simpler shape like a diamond, but I like the way this looks. So I'm just gonna try and recreate this while having this right there for reference. So let's go ahead and create an empty and name it grass. I'm going to center the position, and I need a mesh filter and mesh renderer and box collider. So let's add a mesh filter, mesh renderer, and box collider. I'm just gonna disable the other grass for now. And currently you can see that we don't have a model or anything. So I'm gonna go ahead and assign the mesh filter to be the grass model that I created earlier in Blender. And the mesh renderer, that's where I would set the material, but we don't actually have our grass material yet. So for now, I will just set it to this grass material here that doesn't actually deform or anything, it just has the coloring. And then our box collider, I believe I'll want it to be a little higher up, maybe a little taller. But as long as it surrounds the grass, that should be okay. So this effect is achieved in two parts, one by the shader and the material for the grass, and the other part is done by a script that we would attach to our grass. So in our tutorial folder, I'm going to create a script, and I will call this grass tutorial. And I called it grass tutorial because I have another script already called grass in this project, but you can feel free to just call it grass. So I'm just going to start with the script first. So let's go ahead and open up our grass tutorial script. And I'm just going to move my other scripts to my other monitor for reference. And to start, I am going to get rid of the start and update functions here. And up here, I will also be using system.collections.generic. This allows us to use lists. And then in here, we will want a reference to our material. So I will call this grass mat. Then we'll want a reference to our mesh renderer. And I will just call this mesh renderer. And it is from the mesh renderer that we will get our grass material. After that, I want a list of transforms. And I'm going to call this entities. And this is just going to be a list of entities that enter our individual grass blades collider, and they get added to the list. just so we know if anything's interacting with it and where it is, so then it can be offset in whatever direction. The next thing I'll want is a Boolean for when the list is empty, and you could just check the count for the entities, but I like doing the Boolean this way so it's easier to read. And next I will want a float, and I'm just going to call this POS or POS for position and set it to 0. After we do that, in our awake function, we will want to set our mesh renderer. So mesh renderer, I'm just going to say get component mesh renderer. And if you remember on our grass object where we'll attach this script, there is a mesh renderer that we attach to that object. So it should be able to get that component. And then the next thing I'll do is grass mat equals mesh renderer dot material. And I'm doing dot material here instead of dot shared material because I only want to affect the material assigned to this specific blade of grass in this script. That way we can have multiple entities interacting with the grass at the same time. And when one grass is affected, the other grass on the screen won't be affected if it's not being touched. I hope that made sense. So then we will want to keep track of the entities that enter our grass blades collider. So we will do on trigger enter and on trigger exit. And in on trigger enter, we will want to add the entity to the list that is colliding with the grass. So we will do entities.add other.transform. And then since we're adding something to the list, empty list is going to be false. And the position will be set to 0 here. And this position will make sense more later. It is essentially how the grass reforms to its original shape over time. And we will be doing that in a fixed update loop later on. But for now, just trust me that you'll want to set it to 0 here. And then on trigger exit, we will want to do entities.remove other.transform. So once it's done colliding or leaves the collision area, it will be removed from the list. And now we will want to do that fixed update loop that I was talking about earlier. All right, I'm rereading my code from before and it's not quite making sense to me, but I'm just going to trust that it works. So if entities.count is less than or equal to 0, and then inside of this if statement, we're doing if it is not an empty list. So the list is empty here, but then we're saying if it's not empty, we will have a vector 3 called current grass mat os. So current grass material position equals our grass material dot get vector underscore position. And this is going to be a value inside of our shader, the underscore pos for position. That will be inside of our shader graph once we create that for the material. And then we'll do grassmat.setVector, and we'll be setting a value to that position vector. And we'll want it to be the current position plus a new vector 3 with 0 in the x, our position value in the y, and 0 in the z. If our position value for this script is greater than or equal to 50, and you can set that 50 to be a variable up here that you can change to find what works best for you, but I'm just going to stick with 50. Then we're setting empty list to true, and every time this updates, our position is increasing by a small amount. So it looks like it's doing plus equals 0.0025 for the float value there, and it will every frame update and increase by that amount so that the grass eventually goes back to the upright position instead of remaining trampled and flat. And then after that, we will want to return and not run this next part of the code, where if entities of entities.count minus 1, and this just grabs the last entity in the list, the last transform value, and we're just checking to see if it is null, then we will also return and not run the next thing. However, if it is not null, then this next part happens where we say grassmat.setVector, and it's going to be that position vector. And we're saying entities, that entity at the last position. So .count minus 1 .position. So we're essentially setting the position vector in our material shader to the position of the last entity in the list of entities. So it'd be the last one to enter the collider for this blade of grass. And just to make a little more sense of this, so empty list is really just a way to track if and when to allow the grass to reform and point upward again. It's not actually checking if the list is empty. It's just kind of if the list happens to be empty and this empty list variable hasn't been set to true, then the grass blade that has this script in particular is still resetting based on our position value here. So I'll go ahead and save this, and I will put the whole thing on screen in case you need to copy it. You can also grab the project from GitHub if you'd like. The link should be down in the description. And let's go ahead and minimize this. And on our new grass, let's go ahead and attach that grass tutorial script. There we go. And now our new grass looks exactly like our other tutorial grass in terms of components. And now for the shader graph. So to create the shader for this grass that will allow it to look like wind is blowing and then also allow our player to deform it, we will go ahead and create a shader graph, URP, and lit shader graph. And I will call this grass tutorial shader graph. And I will go ahead and bring this over here, make these a little bigger so we can all see it. And first I'm going to add our components. And the first thing I'll want is a texture, and I will just name this main text. Then we want our vector 3 for position, and I'll call that pos for position. And the reference here, you'll want it to be _pos. Then I will add a float for effect distance, a float for rotation amount, a float for wind speed, and a float for wind strength. And the first thing I will do is get the color set up. So let's grab our main text. I'll put it into a sample texture 2D LOD, and then we can just take the RGBA output of this and put it into base color 3. And now if I save this, let's go back to our game, and our grass is right here. But to make sure it's using our new shader, I'm just going to go ahead and create a new material, and I'll call this grass tutorial mat, and I will apply it to our grass, and you can see it is all white. And to make sure that our shader is applied to this material, we'll just take our shader graph and drag it onto the material. And now you'll see the inputs have changed, and I will change this to my texture palette for my grass that I used. And now I have my color on the grass, which is great. So going back to our shader graph, let's first create the wind. So I want to create a position node, and I'm going to set it to world position. And then I want to split the world position, and I will want to combine it with R going to R and B going to G. And really what I'm getting here is the X and the Z position for world space. And that is just going into this combine node so that I can use it to go into tiling and offset into the UV input here. And that will just make it so that the wind is consistent across grass blades throughout the world space. And then I will create a time node, and then I will want to multiply. And I want to multiply time by wind speed. So this will control how fast the wind is. And then for my output, I will plug that directly into offset. And for tiling and offset, I want that to go into the UV input for a gradient noise, node. And I'm just going to change the scale here to like 7, just because I know that works well. And then I will also want to highlight these 3 nodes, Control C, Control V, bring them down here. I will change the gradient noise scale on this one to 5, just so it's a little different. And instead of going directly into multiply with wind speed, I'm just going to go into another multiply here, set it to a negative value, and I'll just say -2, and then plug that into our other multiply node. So now these should be going in opposite directions. And I'm just going to go ahead and set a default for our wind speed to be 0.1. And now if we look here, we'll see that our noise is actually moving. And what we'll want to do now that we have noise going in different directions, is multiply them together. So we'll take our output for both of them and just plug them into a multiply node. And now they just kind of do a little interference with each other, which looks nice. Then from that, we will want to go into another multiply node, and this time with wind strength. And for wind strength, I will set our default value to 1. So it's not really doing anything yet, but if you wanted to decrease it to weaken it, then you could, to make it have no wind. And if you want to increase it, then the wind will really affect the mesh. Like the stronger the wind strength, the more the mesh will move based on the noise. So for now, I'm just going to set it to 1, and I'm just going to move this up and over. And from here, I want to create another position node, but this time I want to change it to object space. So this is going to be space for the mesh that is attached to our object for this material. And I will once again feed this into a split node, and I want to multiply by G, which is our Y value. So let's go ahead and multiply our noise by our height, and you'll see that at 0, nothing is happening. So this is to make sure that the grass doesn't detach from where its root is and fly all over. Now, I will make another position node here, and I will also set it to object space, and I want to split it again, and I want to create a combine node, and I am going to hook up G to G, B to B, and I'm only going to have this affect the X direction, which is R. So R is X, G is Y, B is Z. The Y and Z position of our objects, vertices are not going to be affected, but I will have it affect the X position. So horizontally, it'll be moving in the wind. So to do that, I want to do add, and then hook this up, and you'll see it gets nice and wavy here. So I'll go ahead and hook that up to our output. And for all of this, I want to group it. So I will do group selection, and I just want to call it wind, just so that later on I know what these nodes do. It's always good practice to do that. And I will take our RGB3, which is going to be the XYZ positions, and I will plug that into the vertex node over here for position. And if we save and go back, our grass should be moving. So as you can see, it is not moving, but that is because our wind speed is set to 0 and our strength is set to 0 as well. But if I set those to what our default values were, our grass is currently moving, which is nice. And to make this look a little bit better, I am going to just get rid of our old grass. And for our new grass, I want to make a little field of it. So I will make 10 of them and then highlight them all, go into position, and I want them to be linearly laid out between -10 and 10. See how that looks. No, maybe it could be -5 and 5. Okay, that looks okay. And I'm just going to copy that L -5, 5 because I will create an empty, call it grass line, put these pieces of grass into our grass line after I reset the position of it. And then I will duplicate this so that there are 10 of them. And in the Z position, I will paste that L -5, 5. So that way we have our little field here. And I will say it does look like it's moving maybe a little too much. So I will actually decrease the strength here. So maybe like a 0.5 will look better. Maybe a 0.33 for strength. I think that looks best. And while I'm at it, I will just go ahead and say grass square. Reset the position of this. And I will put all of those grass lines into my grass square. And now I have a object with just a square patch of grass that has 100 of our grass blades in it. And that will just make it easier if I want to add some more grass to this plane. To better spread out the grass, it might be a good idea to get like a prefab paintbrush tool. But for now, I'm just manually placing it. Anyway, back to our shader graph, and we will add the displacement functionality now. So I will need my position node. I will need effects distance and the rotation amount. For the effects distance, I'm going to say the default can be 2.5. Rotation amount, I'm just going to have the default be 0. And the position we don't have to worry about because that's going to be filled in through our script. The first thing I'm going to do is create a position node set to world space. And then I want to subtract the world space value with our position value. And then that will go into a split node. And we will create a combined node as well. And from here, our X value will actually want to go to the Z value. And I'm doing all this just to get like the vector direction from the current position of what's interacting with the grass and the grass position itself. And just to make it so that the grass bends away from the thing that's interacting with it rather than towards it. So for the Z value, I'm actually going to plug that into a negate node and then plug this into the R on the combined node, or X. And I'm not exactly sure why I have to do this. When I was figuring this out, this is the way I found to get the grass to actually just bend away from the thing interacting with it. So I'm sure the math somehow works out here, but I didn't take the time to actually learn how the math works. But just playing around with it, I found that this works. So there might be a simpler solution, but hey, this works. I'm actually going to get rid of these little nodes right here for now because I don't need them quite yet. From the combine node, I will plug this into a normalize node. And this is just going to normalize that vector that we're getting. And once again, this normalized node is going to go into a negate node. So I'm not quite sure if you actually need this negate node or if you could just do something earlier on that makes it so you don't need it. I'm going to keep it because it works with it, but you might not need it. And from this negate node, I am going to plug in the output to a rotate about axis node and put it into the axis input. And I want to change this from radians to degrees. And for the input here, for the rotate about axis node, I want it to be a position node, but I want it to be the object position. And then as far as this rotation node goes, I will actually go over here and add another position node for world position and take the position node here and I want to plug them both into a distance node to get the distance between them. And I will take this distance and plug it into a clamp node. And I want the maximum to be that effect distance value. And effect distance is just how far away that the thing interacting with the grass actually has an impact on whether or not it rotates. So that's why I'm clamping it between these values. And I actually want the minimum to be 1 here. And then out of this clamp node, I will go into a divide node. And I want it to be the denominator, so I'm plugging it into B. And I want the numerator for the divide node to be the rotating amount that we select. And this way, the grass that's affected rotates more when it's closer to the object that's affecting it. And grass that's still affected but a little further away will rotate less. And from this divide node, I will plug it into rotation. And of course, we only want to rotate when we're within the effect distance. So I will do a comparison node, and I want it to be greater or equal. And then we'll also have a branch node, and the comparison is going to be the predicate. So whether or not something's greater or equal, then we'll do either true or false. For the true value, it is going to be rotate about the axis. And for false, we just want it to be the regular object position. And for the comparison, we are comparing effect distance here to the distance between the thing that is affecting our grass blade and the world position of the grass blade itself. So if our effect distance is greater than or equal to the distance from the affecting object to the grass blade, then we will rotate about axis and do so based on how close the object is or how strong of a rotation it is. And if our object is further away than the effect distance, then we will just not rotate and pass the object's position. And for this, I do like cleaning stuff up a little bit, so I will just highlight this and then I can do convert to subgraph, and I can save it as a new subgraph, and I'll just call it tutorial displacement shader subgraph. And if I open this up, we'll see that we actually don't have an output. And what we want to output is actually just a vector 3. So we'll just go ahead and do this. And I will call this output out vector. And I will save our subgraph. And I will close it. And I'm just going to clear this error because I think we already took care of it. But as you can see, our position, rotation amount, and effects distance goes into that subgraph, and then out we can get a vector. And with this vector, we will want to combine it with our wind. And I will also just group this real quick. And I want to call this displacement. So let's go ahead and add the wind to our displacement vector. And because we're adding those two, I will then want to normalize it by dividing by 2, because we're essentially adding the thing twice here for the position. So dividing it will normalize it, and then that can go into our position node here for the vertex. And if I save this and we go back over here, right now we don't have an effects distance set, so I'm going to set it to our default of 2.5. Rotation amount, I'll say 90. And you can see right now the position set to 0, 0, 0. So in the middle, you can see like how much this is getting affected. So if I just increase this rotation amount, you can see like how the grass is being deformed. And then if I move this around, you can see like where the deformation's happening for the position. Set that to 0. And rotation amount, I will set to, I don't know, let's try 90. And maybe I'll have the effects distance be a little bit higher, so like maybe 5. But really it's going to be dependent on our player or whatever's deforming the grass. So I'll create an empty here, call it player, I will set it to the 0 position. I'm going to add a sphere to represent our player. I'll size it up a little bit, and I want to give it like a nice white material, so I'll create a material, call it white, put it on our player, and then I want to create an empty, and I'll just call this grass collider. And there's nothing really special about this. It's just going to be like a sphere collider that I set as is trigger. And if I increase the radius, we'll see that it is getting bigger. So I'll just set that to like 3. So this is just so that the grass within this collider gets interacted with. So I haven't set like any tags or anything yet. So I just want to see if this will work. So if I go ahead and hit play, and then I move our player around, yeah, it's not doing anything. So for the grass to register that the player is interacting with it, I believe it will need a rigid body. And I'm going to set it to continuous because our player would have a continuous collider. Constraints, I'm going to freeze rotation just because that's what I normally do. And I'm going to go ahead and run this again. And it looks like our grass is interacting with the player. And it does deform, but it's kind of jostling us around. So I think it's because our grass might not have is trigger selected. So it'd be better if these were all prefabs, and then I would only have to change one thing at a time. But since they're not, I'm going to do it this way by highlighting all my grass. And yeah, is trigger is not selected. So I will do that. I selected is trigger here on all of my grass objects. And now, if I were to use my player, it looks like the grass is deforming and we're not getting jostled around. And the grass returns to shape eventually. I do think my effects distance might be a little too high. So I will just set that to like 2.5 like I had originally. And I want to make a field. So I will just grab this grass here, duplicate it, duplicate it, duplicate it, duplicate it, duplicate it, highlight all of this, duplicate it, duplicate it, duplicate it, duplicate it, duplicate it, and I'll delete the extra. And of course you could add like a movement script to your player if you want, but I'm just kind of dragging them around here. The grass is not really doing the like reformation thing that I want, so I want to see if I can figure out why. So looking at my reference material, it looks like my effects distance is actually pretty high. So let's go ahead and set that effects distance to 20 like I had in my reference material. And when I run this, I can move my player. Let's actually just do it like this because this is easier. And yeah, you can kind of see, it might be hard to see on YouTube, but you can see the grass deforming and then over time going back to how it was. And just to make sure I have this right, I'm actually just going to hide this player that we just created. And from my references, I do have prefabs, or actually I don't have prefabs. In my references, in my other scene, in my sample scene, I have a player and random walking enemies. I will copy those over to my new tutorial scene and we'll paste. And I want to just make sure that the player here, I can move around and it is deforming and it's leaving a little bit of a trail. And if I were to enable all of those enemies, the random walking enemies, they also are interacting with the grass and leaving a little bit of a trail. So awesome. Anyway, I believe that will do it for this tutorial on how to do the tunic-like grass, where you can interact with the grass, deform it, have other entities interact and deform it, and they also only interact with it if they are touching it. So if you bring them up in the air, it's not going to deform the grass. You bring them back down, they'll start deforming it. Put them underground, they're not going to be deforming it anymore. So yeah, it's pretty performant. I wouldn't overdo it with your games if you're using this implementation. But yeah, you can definitely get some good grass out of this. So if you like this video, leave a like down below, leave a comment with what you would like to see next. Feel free to subscribe, and thank you for watching. Bye.